Hello student, today I am going to discuss match pair t-test or testing the difference between the means of the two dependent sample. As you know, there are basically three types of t-test. A one sample t-test, the mean of a single group against a known mean. Secondly, an independent sample t-test compares the means for two groups. The two types I have already discussed and I have given the link of the two videos in the description box. And now I will discuss a paired sample t-test compares the means from the same groups at different times, or simply the match pair t-test. The match pair t-test or the paired sample dependent t-test is used when the data from the two groups can be presented in pairs. For example, where the same peoples are being measured in before and after comparisons, or when the group is given to different tests at different times. For your further clarification, I will take one example. A company want to impose a training course for the development of the skills of their employee. Now the company wants to verify whether the training course is improved the performance of the employees or not. For that, they take similar test of 12 participants both before and after the training course, and the marks obtained of the participants before and after the test was recorded in the same order. Now the company want to judge was the course useful or not. So in order to get the correct results of these situations, you will have to apply the match pair t-test. Clear? Here one things you should remember. For a pair t-test, it is necessary that the observations in the two samples be collected in the form of what is called match pairs. That is, each observations in the one sample must be paired with an observations in the other sample in such a manner that these observations are somehow matched or related. Clear? Now to apply this test, we first work out the difference score for each matched pair and then find out the average of such differences, which is denoted by d bar, along with the sample variance of the difference scores, which is denoted by s. If the values from the two matched samples are denoted by xi and yi, then the differences will be di equal to xi minus yi. The mean of the differences will be d bar equal to summation di divided by n. And the standard deviations of the differences is denoted by s equal to root over summation d minus d bar whole square divided by n minus 1. Now we can apply the pair t-test for judging the significance of mean of differences and work out the t-test, which is t equal to d bar minus 0 divided by s into root over n. Here the degrees of freedom is n minus 1, d bar equal to mean of differences, s equal to standard deviation of differences, and n equal to number of matched pairs. Now this calculated value of t is compared with its table value at a given level of significance as usual for testing purpose. Now I will solve a mathematical problem to get the idea more clear of this. Here the similar kind of math has given. To verify whether a course in accounting improved performance, a similar test was given to 12 participants both before and after the course. The original marks obtained in alphabetical order of the participants were 44, 40, 61, 52, 32, 44, 70, 41, 67, 72, 53 and 72. After the course, the marks recorded in the same order were 53, 38, 69, 57, 46, 39, 73, 48, 73, 74, 60 and 78. Now you will have to judge was the course useful at 5% level of significance or not. Now in order to solve the problem, first you will have to adopt the null hypothesis H naught. The course was not useful, or there is no significant difference between the marks obtained after the course and marks obtained before the course. And the alternative hypothesis H1 will be just opposite of the null hypothesis. The course was useful, or there is a significant difference between the marks obtained after the course and marks obtained before the course. Now you will have to write down the formula of match pair t-test, where t equal to d bar divided by s into root over n. Now you will have to find out the value of d, the value of s, and the value of n. The value of n has given in the math, that is 12 participants was given the test. So the value of n will be 12. S is the standard deviation of differences, and the formula is root over summation d minus d bar whole square divided by n minus 1. Now how to calculate d? As I have told, if the values from the two matched samples are denoted as x and y, then the differences d will be x minus y. So here also we have got the two matched sample. One is marks obtained before the course and the marks obtained after the course. First one is denoted by x and second one is denoted by y. Now in order to get the solution done, we will have to make some column. First column is x, which is representing the marks obtained before the course, and the second column is y, which is representing the marks obtained after the course. The corresponding value of x column I have written, which has already given in the math, that is 44, 40, 61, 52, 32, 44, 70, 41, 67, 72, 53 and 72. And the corresponding value of y column that has given in the math that I have written, that is 53, 38, 69, 57, 46, 39, 73, 48, 73, 74, 60 and 78. Now in the next column we will have to calculate d, where d equal to x minus y. So under this column we get 44 minus 53 equal to minus 9, 40 minus 38 equal to 2, 61 minus 69 equal to minus 8, 52 minus 57 equal to minus 5, 32 minus 46 equal to minus 14, then 44 minus 39 equal to 5, then 70 minus 73 equal to minus 3, then 41 minus 48 equal to minus 7, then 67 minus 73 equal to minus 6, then 72 minus 74 equal to minus 2, 53 minus 60 equal to minus 7, and 72 minus 78 equal to minus 6. And now you will calculate summation d. So after adding all the value we get summation d equal to minus 60. And now also you will have to calculate d bar. As you know, the formula of d bar equal to summation d divided by n. So here summation d equal to minus 60 divided by n equal to 12. So you will get the value of d bar equal to minus 5. Now in the next column you will have to calculate d minus d bar whole square. So you know the value of d bar equal to minus 5. So to get the d minus d bar whole square, we just put the value of d bar each and every row. So first row we have seen the value of d equal to minus 9 minus 5. Minus 5 is the value of d bar. So minus 9 minus 5 will be minus 4. So minus 4 whole square will be 16. Similarly, the value of d in the next row, we see the value of d equal to 2. So 2 minus 5. So we get plus 7. So definitely plus 7 whole square will be 49. Similarly, in the next row, the value of d is minus 8 and the value of d bar as usual it is minus 5. So minus 8 minus 5 will minus 3. So minus 3 whole square will be 9. Again in the next row we see the value of d equal to minus 5 and the value of d bar equal to minus 5. So minus 5 minus 5 will minus 5 plus 5. So you get 0. So 0 whole square will be 0. So such a way you will have to calculate the rest other d minus d bar whole square value. So the rest other d minus d bar whole square values are 81, 100, 4, 4, then 1, 9, 4, 1. So adding all the value of d minus d bar whole square, we get summation d minus d bar whole square equal to 278. Now putting the value of summation d minus d bar whole square equal to 278 and the value of n equal to 12 in the formula of s, means the standard deviation of differences, which I have written root over summation d minus d bar whole square divided by n minus 1, we get the value of standard deviation equal to 5.03. Finally, we get the value of d bar equal to minus 5, the value of standard deviation is equal to 5.03, and the value of n equal to 12. Putting the all value in the formula of t, that is d bar minus 0 divided by s into root over n, we get the value of t equal to 3.443. As you know, t is in the modular sign, so the value of t will never become negative. Clear? So now you will have to calculate degrees of freedom. Here the degrees of freedom is n minus 1. So we get 12 minus 1 equal to 11. So for degrees of freedom 11, the tabulated t at 5% level of significance is 2.201. But we get the calculated value of t is 3.443. So as the calculated t is greater than tabulated t at 5% level of significance for the degrees of freedom 11, so the null hypothesis is rejected. So the course was useful. Clear? Here most of the students are getting confused that where they should identify the tabulated t value. Student, you should remember one thing, the tabulated t value usually given in the math. If it is not given, then definitely you will get the t table where you will get the value of t at different significant level with their respective degrees of freedom. Clear? Here I will show you how to find out the tabulated t value from the t table. So first see, in the left hand side you will get the degrees of freedom, and in the right hand side you will get the level of significance for the two-tail test and the level of significance for one-tail test. So in this math you will have to check out at 5% level of significance your null hypothesis is accepted or rejected. So now see here the degrees of freedom is 11. So at 5% level of significance the tabulated t value is 2.201. where the degrees of freedom is 11. So here you should remember one thing, you should always consider the level of significance for two-tail test, not for one-tail test. Okay. So such a way you will have to find out the tabulated t value from the t table. Clear? That's it.